Hello, myself Anirban Kishos. Today I am going to explain Chapter 9. It is Structural Remodeling with the subject Digital Circuit Design using Verilog. In this chapter, we will study briefly about structural modeling. The first is module. We have already came across module in the first chapter. Let's see again what is module. A module defines a basic unit in Verilog HDL. It is of the form module, module name, and port list, declaration sequence, and module. Ports. A port can be declared as input, output, or in-out. A port by default is a net. However, it can be explicitly declared as a net. An output or an in-out port can optionally be declared as a RAG register. In either the net declaration or the register declaration, the net or register must have the same size as of the specified in the port declaration. Here are some examples of the port declaration like PC and STR next set, where PC is the input and these two are the output. Module instantaneous. A module can be instantiated in another module, thus creating hierarchy. A module instantaneous statement is of the form module name, instantaneous name, port association, where this is the basic syntax of module instantiation. Port associations can be position, or can be by position or by name. However, associations cannot be mixed. The port association is of the port expression, port name, port expression. This is by position and this is by name. Port expression can be of the following: an identifier, a bit select, a part select, concatenation of the an expression. In positional association, the port expressions cannot connect to the ports of the module in the specified order. In association by name, the connection between the module port and the port expression is explicitly specified, and thus order of port associations is important. Here is an example of a full header built using a two-header module. Half header, A, B are the input and SC are the output. Here the and output are defined briefly, and here are the parameter. Then we assign the zone and the end with delay and module. And here is a full header module, full header, and then port list. Then we define the where statements where the input output parameter are defined, and then module instantaneous statements are given, and module. Then we have finally the end module. Unconnected ports. Unconnected ports in an instantaneous can be specified by leaving the port expression blank, such as in the following, like this. Since after QS there are between commas there is a gap. Similarly, after D and CK between commas there is a gap. Like this, these are unconnected ports. Different port lengths. When port and the local port expression are of different lengths, port matching is performed by right justification or try negation. Here is an example of the port matching. These two are the example of different port lengths. What is a module parameter values? While a module is instantiated in another module, the higher level module can change the value of parameters in a lower level module. This can be done in two ways: deform statement, module instance parameter value statement. Let's see what is a deform statement. A deform statement is of the form deform higher path name 1 value, higher path name 2 value 2, and so on. Hierarchical path names of the parameters in a lower level module can be explicitly set by using such a statement. Here is an example. What? This is an example. Module top new A, new B, new S, new C. And here we declare the input output. And here is the def param HA1 short delay is equal to 5. HA1 and delay is equal to 2. Where short delay is given as 5 nanosecond and delay given as 2 nanosecond. Then we give the statement HA1 new A new B then N module. Here is another similar example of def param. Module instance parameter value assignment. In this method, the new parameter values are specified in the module instantiation itself. Here are few examples given. Let's look at the first example. Module, then module name, then new A, new B, new S, new C, where the input and output statements are briefly described, and the module instance parameter value assignment is given. The first value 5 is the parameter and delay. The first parameter declared in module HA. Second value 2 is for the parameter ZOT delay. The second parameter declared in module HA and module. Similarly example has been given in here. This is also a similar example of module instance parameter value assignment, same as the first one. Let's see the external port. What are external port? In the module definition we have seen so far, the port list describes the list of ports visible outside the module. For example, module scram A, ARB, control, where these are the port lists are given. Input and all the output are described in module. The module ports are ARB, CTRL, MEM, BLK, and byte. These are also the external ports. That is, in an instantaneous, the external port names are used to specify the interconnections when associating ports by name. There is an syntax. Scram A as sh dot byte p1 dot mem m1 dot ctrl c1 and so on. In module Scram A, external port names are explicitly specified. Verilog HDL provides an explicit way to specify external port name. This is done by specifying a port of the form external port name and internal port name. It's the same example, but the external ports are explicitly. Here is an example. Let's see the example. Module Scram B. Then the external port syntax is given in here, and the internal and the input and the output are specified in N module. An internal port can not only be an identifier, it can only be of the following: a bit select, a part select, a concatenation of bit select, part select, and identifier. Here is an example. Module Scram C. The syntax of the input internal port, and the input and the output part is described. Finally, the N module. In the module definition of Scram C, here the port list contains a part select, ARB this one, an identifier, CTR, concatenation this one, and a bit select this one. Since it is since the here we have studied the internal port can have these three. These can be of the following disk type. In the case of the internal port is a bit select, part select, or a concatenation, no external port name is implicitly specified. Uh, here is a similar here is a similar example. This is also a similar example of internal port and external port. Let's see this example. Modules can an internal port be connected to? Yes, Verilog HDL allows an internal port be connected to more than one external port. Yes, Verilog HDL allows this. Here is an example. Let us see this example. Module fan out dot a control in dot b con out c dot c con out. The input and the output part assign conned out equal to control n. The internal port conned out is connected to two external ports. Can you see here? B and C. So the value on conned out appears on both C and both B and C. Thank you.